So the topic we are going to discuss in this video is mesh analysis of AC circuits. So mesh analysis is another type of circuit analysis. So here we are going to discuss mesh analysis for AC circuits. So analysis of AC circuits, suppose the circuit is given. So we have to see whether the circuit is in time domain or frequency domain. So here the given circuit is in frequency domain. You can see that there is a current source here which is represented in phasor form, and there is an inductor here which is again represented in phasor form. Similarly, we have a voltage source here which is also represented in phasor form. So the given circuit is directly in frequency domain. So we can directly move on to the mesh analysis steps. So here in the mesh analysis, the first step is to identify the meshes in the circuit. So here we have three meshes, and in the problem statement itself they have given the mesh currents. So here is first mesh, the current assigned is I1, and this is the second mesh and the current assigned is I2, and this is the third mesh and the current assigned is I3. So next step is to assign polarities depending on the direction of the current. So let us take this mesh 1, and there is a current here. So the current direction is given as clockwise. So let us assign the polarities for this. So for this resistor, it is plus minus, and again this current flows here. Again these are all passive elements, so we'll have a voltage drop in these elements, so we just take it as plus minus, and again here plus and minus here. Now this is the first mesh. Now let us take the second mesh. The current is I2, the direction is again clockwise. So already we have assigned polarity for this capacitor on the basis of current I1. So let us move on to this capacitor. So the current will enter here. So this will be the positive terminal and this will be the negative. Again here this is positive and here it is negative. So this is mesh 2. And let's move on to mesh 3. So mesh 3, we can see that these are the three components. We have a current source and a capacitor in common with mesh 2, which has been already assigned polarity, and similarly there is an inductor which is in common with mesh 1, and polarity of that is also assigned. Now all the components are assigned with the polarity. So let us move on to writing the mesh equations. So first mesh, so we have to apply KVL equations, that is Kirchoff's voltage law equations. Okay, so Kirchoff's voltage law is the sum of voltage in any closed circuit is equal to 0. So let us write the Kirchoff's voltage law equation here. So here the current moves from plus to minus, so we can write it as minus 8 I1. Then for the inductor, again it moves from plus to minus, so it is minus of J10. We have two currents common here, so it is I1 minus I3. I1 flows in this direction and I3 flows in opposite direction, so we are writing I1 minus I3. And the next is this capacitor, again it is from plus to minus, so we'll be writing as minus J2 into, here also we have two currents flowing in this branch, so I1 it flows in this direction and I2 it flows in the opposite direction, so we'll be writing minus of minus J2 into I1 minus I2. So this is the first mesh equation. So sum of all these voltages will be equal to 0. So if we simplify, we will be getting this equation. Next is mesh 2. So mesh 2, again we'll start from here. So here this current I2, it flows from minus to plus. So we'll put plus of minus J2 into, again current flows, I1 is flowing in the direction and I2 is flowing in this direction, and we have written polarity based upon this I1. So it is plus of minus J2 into I1 minus I2. And then for this capacitor, it is from plus to minus, so it is minus of minus J2 into I2 minus I3. And for this, minus of 4 I2, and the current flows into the voltage source, so it is minus 20 angle 90 is equal to 0. So this is mesh 2 equation. And we move on to mesh 3. We have a current source here with the value of 5 amperes. So current I3 will be equal to 5 amperes directly. So from mesh 3 we can write I3 is equal to 5. So substitute the value of I3 is equal to 5 in this equation and this equation, and simplify the equations. So here we have two equations with two unknowns, I1 and I2. Now again this can be written in the matrix form as like this. So 8 plus J8 J2 into vector of I1 I2. Here we have J2 4 minus J4, so that is written here, and in the right hand side we have this J50 and minus J30. So this equation is written in the matrix form like this. Now we have to find out the value of determinants. So let us find out first delta. So determinant, simplify the complex number and find out the value. Next is we have to find out del 2. Here they have asked the value of current I0. I0 is actually flowing here, right? So which is in mesh 2. So current I2 flows in this direction and I0 flows in this direction. So both are in opposite directions. So I0 can be written as minus of I2. So if we find current I2, then negative of current I2 will be equal to I0, right? So here to find I2 we have to find out first del 2. How can we find del 2? Del 2 is, we have a determinant here, replace the second column with the right hand side value and find out the value of del 2. Now I2 can be found as del 2 by del, substitute the values and find out the value of I2. Now we have to find out I0. So I0 is opposite of I2, so it is minus of I2, and this is the value of current. So the steps in the mesh analysis again here is, first see whether the given circuit is in time domain or frequency domain. If it is in time domain, convert the circuit into frequency domain. Then identify the meshes in the circuit and assign mesh currents for that circuit. Then using Kirchoff's voltage law equation, write the mesh equations and form this matrix. Then we can find out the value of determinants and correspondingly currents I1, I2, etc.